Hello, everyone. Good morning, good evening, good afternoon from everywhere you are. I'm so happy to be here with another exciting session with Josh. Today, Josh wants to talk about the cloud infrastructure specific for developer. Before he starts his session, let me share some information with you about our community and our calendar. As you know, Microsoft Learn community, we are part of the Microsoft Learn community. You can enjoy from a set of learning content from Microsoft Learn. You can ask your question from a lot of experts, and also you can find your learning content based off the role, certificate, or other things. You can join from aka.ms Microsoft Learn community. Don't miss that. We had this is a July calendar from Microsoft Zero to Hero. We will share as soon as possible August calendar. Also, you can have access to last session from our YouTube channel. You can see a lot of session. And the last slide is about our code of conduct. Be aware of others, be friendly and passionate, be welcoming and respectful, be open, all question and viewpoint, be understanding of different, be kind and considerate to other in the chat, in the question, or the things. Now the time is at the Josh in the stage. Hello, Josh. How are you?
Hello, I'm doing well. How are you?
I'm fine, thank you. Thank you. I think the topic is very interesting, cloud infrastructure, especially for developers. As you know, I think it's very useful for developers to improve their knowledge, to working with the cloud infrastructure.
hmm Absolutely, and it's less about needing to know everything about everything, and more about knowing where to find the right information and
Yeah,
being able to figure out the right things to pick, understanding what your application is actually capable of doing and expected to do. So, hopefully, throughout the course of this presentation, we'll impart some knowledge and give you all a couple of extra tools that you can put in your tool belt to help really solidify that knowledge transfer, as well as start to look at things with a bit of an infrastructure lens. I won't say a complete lens, but
exactly. Okay, the stage is yours. You can start.
very good. Well, thank you, everyone. Again, my name is Josh Garverick. I am here to talk about cloud infrastructure for developers. Yes, for developers. Um, a lot of what I've seen over the past several years is that there's a lot of different um, expectations that are out there for developers, not only for writing good code, clean code, making sure it's tested, making sure it's secure, but also trying to figure out where best to put it so that it can meet its potential and actually satisfy the requirements that you wrote the code for in the first place. So, what we're going to talk about today is a quick intro of me. We're going to talk about core patterns. And this is less about being focused on, Microsoft Azure or AWS or GCP, and more about the really high level understanding of how your application does what it does. We're also going to talk about some abstractions that are helpful for devs, especially kind of new to the infrastructure realm. We'll talk about some extensions as well, some nice IDE plugins that can help you do quite a few things, and some emulators as well. And this is helpful, especially for local testing, or if you don't happen to have access to a cloud account to be able to stand up different types of resources. This can also be helpful for doing that. So, and then we'll talk a little bit about the pace of progress, because inevitably, as we all know, things change at a very rapid clip, and trying to stay current with everything that's going on in the cloud world can be very challenging. So, we'll talk a little bit about how to manage that potential either anxiety or feeling of being overwhelmed when it comes to just the amount of information that's out there. So about me, I was just thankfully re-awarded my Microsoft MVP award for the 10th year, which to me is a big milestone. It's a nice validation, and it's definitely something that I'm very grateful for, having the opportunity to work with you all in the community and spread the good word. So I've gone through, I have done some certifications, just a couple. I'm from Buffalo, New York, USA. For those who are not really familiar with where Buffalo might be, if you know where Niagara Falls is, we're not far from there. So maybe 45 minutes drive to Niagara Falls. So we're in that general area. There's my Twitter handle. I refuse to call it X. It's just it's a personal policy of mine. And then my GitHub URL as well, in case you would like to go check out the things that I have out there on my public repositories and subsequently make fun of any code that I have. So I always like to start my talks with what you should expect to get out of this talk. So the TLDR, or too long didn't read, of this is really around 3 points. 1, remember the Ian Malcolm principle. What's that? We'll talk about that in just a moment. Simplicity is better than complexity every time. As engineers, I know we do have a tendency to like to integrate a lot of different types of things, especially if it's a newer technology or it's something that we feel would be very beneficial to solve the problem at hand. Sometimes it's better to take a step back and really look at what you're trying to put together, how it needs to perform, and what purpose it serves in the overall ecosystem that it's a part of. And then finally, don't boil the ocean, boil potatoes. It's a kind of a goofy saying, but the underlying message here is don't try to solve everything all at once. Do things that are practical. You wouldn't necessarily want to boil the entire ocean, but you may want to actually take a more practical approach and just really look for ways to solve your problems without creating too much of a headache and without using too much overhead. Now, I mentioned that we should keep the Ian Malcolm principle in mind. And this is a reference to the movie Jurassic Park, in which Dr. Ian Malcolm, seen here on screen, had a quip about people being so preoccupied with whether or not they could.
Josh,
yes.
Sorry to interrupt you. And I think your screens have an issue because it's not fit in the screen. And
oh, no.
I think it's just zoom out. It's more zoom in, you need.
I am terribly, terribly sorry. I don't know what happened there. We will just resize. How's that?
It's okay. Now it's okay. Thank you.
Okay. Very good.
Sorry. Okay.
No, thank you for letting me know. I didn't realize that it would have resized like that on me on the fly. So,
okay. Go ahead.
All right. Thank you. So, as I was saying, Dr. Ian Malcolm is a character in the Jurassic Park movies, and he has this saying about people being so preoccupied with whether or not they could, they didn't stop to think if they should. And more simply put, that just means just because you can or have the ability to do something doesn't necessarily mean that you need to do that. Adding unnecessary complexity and kind of going for really big landing spots for your code can be helpful, but it can also create a lot of unnecessary noise for folks who may not know the technology and can add unnecessary complexity when it comes to things like deployments and all of that. Yeah, I'm looking at you, Kubernetes. So when we talk about core patterns, I'm afraid you're going to need to know a little bit about networking. I don't know about you, but I think generally speaking, there are some jokes around in the engineering communities around developers not necessarily wanting to know or needing to know much about how networking works and how things talk to each other. I would challenge that position. I think it's important to understand how your application communicates with other components, other interactions, outside user interactions, and really understanding what that flow looks like. Because it can impact what your development flow looks like. It can impact your code, and it can ultimately impact what you use to host that code. Choose patterns that are agnostic as much as you can. And that may sound a little silly because, well, clearly we want to use this time to go through and talk about Azure and some of the services that you can choose to host your applications in. But this goes more towards that really high level view of what your communication flow in your application looks like, what the requirements are. Is it something that's going to be under a lot of stress? Is it going to be used heavily? Is it something that needs to only be powered on while it's working, and the rest of the time it can kind of sit idle, powered off without anyone needing to worry about it? So there are some things that at a very high level, at a requirements level, are important to keep in mind, and that should help you make some decisions about where you would like to ultimately host your code. And that kind of ties in nicely to choosing services that meet your application's needs, as well as what you think or anticipate the load or the interaction with your application is going to be. So if you write a microservice, for example, and your expectation is within the first couple of months of it being live, it'll receive a moderate amount of traffic, but nothing that will stress it out. Within a few more months, your expectation might be, well, this is going to be triple or quadruple the amount of activity hitting the specific microservice. So planning for that kind of ahead of time and getting yourself at a spot where the services you pick have the ability to be flexible, that's really important. Build security into everything you can. I think that we've all kind of had that hammered home at one point or another with respect to things like DevSecOps, and a lot of folks are really putting cybersecurity in the forefront, and for good reason. I mean, there are data breaches all the time. There are all kinds of other things, ransomware and things like that you see in the news quite frequently. So it's good to be vigilant about that and keep that in your frame of mind when you're developing and when you're looking to host things. And then expect things to break, because they will. And that's one of the biggest challenges I've seen folks struggle with, especially if they're coming from an on-premises or data center hosted world where they've traditionally been deploying to virtual machines or something that's a bit more static and honestly reliable. The ability to be elastic can bring problems when it comes to reliability. So planning for that and making sure that your application doesn't have any unnecessary downtime is also very important. So let's talk a little bit about core patterns from a high level. Now, one of the most common ones I think folks can relate to is that of a static web app, right? You have an application, you're writing your code in HTML, CSS, JavaScript, maybe you're using Angular or React. At some point in this top line, you're going to bundle that code together, right, as a part of your development cycle. And then you're going to publish that to some sort of host to be able to test it, run through different scenarios, make sure that the code that you wrote actually works. The bottom line on here deals with the build, test, deploy cycle that you normally would see with like a CI/CD pipeline. So once you commit your code and you push that up, what happens after that? Build will kick off. You'll run through some tests. Perhaps you'll deploy it to a dev environment. But ultimately, what you really are trying to figure out is, what is this? What is this landing spot that it ends up in, right? So we'll do a quick demo in a minute here, and I'll show you some of the things that you can use to help make that decision. Next up, we have a slightly more complicated situation. Folks may have heard of the CQRS pattern. It's fairly popular, especially with things like microservices architectures, where you've got a need to be able to send messages asynchronously and have them be processed in some sort of a time frame, not necessarily immediately consistent, but eventually consistent, right? You may also have a need to pull information out of a specific data store that reflects those changes. And that might be more of a synchronous or request response type of situation. Being able to understand and break down what these communication flows look like is just as important as the code that you write to issue the commands, to handle the events, and to actually use a querying service to pull that information back in a meaningful way to the end user. So now we're going to talk about fantastic patterns and where to find them. There are a couple of different links that I have in the presentation that go through and give you some additional tools that you can put in your tool belt to help you not only understand and learn more about the different services that are out there, but also help you make decisions on what might be the best fit for your application. One that I like a lot is AzureCharts.com. This has, as you can see, almost a periodic table of elements appeal to it with respect to how the different services are laid out. You can go through and actually click on these, and it will take you to specific product pages. And there are also links in here for specific solution types as well. So you can use this to kind of go through and find, all right, well, what are some of the solutions that are out there already that, pull in things like Azure Key Vault or functions or app services and stuff like that. A secondary and sometimes more interesting, to me at least, site is the Azure Architecture Center. And this will give you the ability to go through and browse different architectures. And why this is helpful is because they give you reference architectures, they give you templates, diagrams, things that you can plug in immediately and start to use and modify for your own needs. Now, there's no substitute for hands-on learning, in my opinion. I think it's important to be able to have the ability to go in and actually tinker with things and see how they work and understand the different constraints and everything that different services have. And that's where one of the in my opinion, best sites, despite it being extremely verbose, is around the Azure Service Limits and Quotas. Now, this will give you, I'll try not to scroll too fast because it might be a bit much for folks. So I want to be cognizant of that. This will give you a per service idea of what you can do with each offering that Azure has. So maybe similar things for AWS and GCP. I'm not sure, but in this case, since we're talking about Microsoft, we're talking about Azure. This site I've used countless times to figure out how it can handle requests per second. So if you're looking to figure out if something is well suited for high volume transactions, you can find out some of the requirements that the cloud services that Azure offers have to deal with here. Now, picking a service for your code to live in is, again, one of those things that you want to make sure you've got as easy of a barrier of entry as possible, so that when you go to deploy it, you're not going to be surprised by anything. You're not going to be scratching your head trying to debug why it doesn't work for 2 days. I've definitely been there, and folks who have tried to get started in the infrastructure world have likely had similar struggles, right? So understanding what offerings are out there from an Azure perspective, what they do, and how they can be applicable to your application. Spend some time and go out and at least peruse the documentation around that stuff, because there's a lot of stuff out there. When we were talking about static web apps, one of the, I think, nicest service offerings that Azure has put out in recent months has been the static web apps service, which allows you to essentially publish a static web application or a single page application directly to a managed static web app. And you can manage all of your stuff from there. You can set up custom domain names. You can set up your SSL certificates and all that stuff. Anything that you might need to do to secure and run a static web app. Now, you can also use a storage account to do the same thing. I personally prefer to go the static web app route because it's specifically built for that, and there's less overhead. There's not as much to worry about, not as much to manage, and generally is a bit more purpose-built, right, for static web apps. Now, you look at things like microservices, CQRS inspired patterns, things like that. There are a few different ways you can put that type of stuff together. People's initial inclination, I think, is typically to go the Kubernetes route, mainly because you can host a lot of different microservices within one Kubernetes instance, one cluster. That's not to say it's the only way to do it. You can use app services, you can use functions. There are a lot of different mechanisms from a compute perspective that give you the ability to host that type of stuff. And if you're starting to get into that infrastructure realm, taking, again, some time to understand what each of those is built for, the type of compute that it's, targeted for, type of applications you can host on it, type of languages that it supports. That's another one to keep in mind. All of these things factor in to making a solid choice for your infrastructure. Now, we're going to start to talk through abstractions, extensions, and emulators. Now, from an abstractions perspective, I'm sure most folks have heard of things like ARM, Terraform. Bicep is one that's come out from the folks at Microsoft, a bit younger than ARM, but inspired by ARM. Pulumi is another one that's kind of been out there for a few years as well. These are all abstraction layers that allow you to create and configure infrastructure to be able to host your applications. Now, there are also some other frameworks and utilities that are out there. I'm not going to go deep into these in this talk, mainly because each one of these is probably a 1 to 2 hour session in and of itself. And I don't believe we have that kind of time. So what I would say is, take a little time, go out and check out each one of these. I know at Build.NET Aspire was a topic of conversation for sure, especially with it going generally available. And this is more to support your developer inner loop. So being able to put together different pieces to host different aspects of your application and do so in a way that's conducive to rapid development. When you come into things like Dapper, which is built specifically for distributed applications, this is more from an orchestration and deployment perspective. It still gives you the ability to select different things in databases, web servers. If you want to use a caching layer, for example, throwing something in Redis, it gives you all of the abilities to do that. And it typically is something that you'll see down the runway, so on your road to production. And then there's also a project out there from another group within Microsoft that's called Radius. And this is something that gives you the ability to do things like application recipes or platform recipes, right? So if you have a whole grouping of microservices that comprise one platform of functionality, Radius can help you not only define what that looks like, but also define the infrastructure as code that goes along with it, and gives you the ability to map through different components, which is definitely useful, especially when troubleshooting or debugging something. Extensions. So I consider this from the point of view of your IDE as well as the command line, because I'm a command line guy. I like it. It makes more sense to me in a lot of cases. It's nice to have some of the IDE plugins, especially for visualizing things like your Azure Resources or any of your Kubernetes clusters or specific things within Docker for keeping an eye on your images. It's nice to have that visual. I personally like to use the command line. So one of the ways that we'll take a look at here in a second to actually generate infrastructure as code that aligns with your application is using AZD, or the Azure Developer CLI. This is based around the Azure CLI, AZ, and installing AZD gives you the ability to kind of bootstrap or set up infrastructure based on the type of application you're developing. So if you're developing an API, or if you're developing a function app or something like that, you can actually use AZD to generate scaffolding around your code that will allow you to host it in Azure. There are also some things within AZD that allow you to then deploy that code or provision that infrastructure. And depending on what type of app you have, what it's written in, some of those things are a bit more reliable than others. So some of the templates that are out there will give you a lot and do a lot of things for you so that it's very simple. Some of them are very no frills or very basic when it comes to what they offer. So sometimes your mileage will vary using those templates. From an extensions perspective, there are extensions out there for things like ARM and Bicep, Terraform, so that you can actually visualize an entire object graph within one of those infrastructure as code languages. There is an extension out there for Azure Functions. So the Azure Functions runtime is something that you can work within your IDE, and specifically within Visual Studio Code is what I personally use most of the time. So there's an extension for that. There's also an extension for something that's called Azurite, which is a great segue into our emulators, because Azurite is an emulator for storage. And what Azurite will do is emulate the behavior of a storage account: blob storage, table storage, and queue storage. It doesn't do files, but it will do those other three types of storage. And that can be helpful when you're working with any type of functions or app services or anything else that use blob storage as a means of either saving or manipulating and reading data from any type of file or any type of a blob structure, right? So that's one that's really handy and helpful. The functions runtime is another one where you can uh, use that runtime as a base image in your application for Docker builds. If you're using containers and stuff like that, um, it's very handy to have that locally. It will run and behave exactly like it would if you were to deploy it to an Azure function in the cloud. And then there are obvious things like Docker and Docker Desktop if you're in a position where that's uh, either free for you or paid for by your employer of choice. There's also Podman, which is something similar to Docker Desktop. I won't say that it's the same because there are differences. Podman's written by Red Hat and allows you to interface with Docker in a couple of different ways that are a bit more Red Hat specific. But the big draw here is being able to work with things like containers, and a lot of these distributions will also have the ability to use Kubernetes either through Minikube, through Micro K8s, or built-in Kubernetes emulators so that you can see how an application would behave locally using those as emulators. Demo time. So we're going to do a couple of things. One, we're going to jump back over here, and I want to at least give you an idea of the different sites that are out here for some of those abstractions. So here we've got the .NET Aspire overview page. This will go through and explain specifically what Aspire is all about. It's very much in the code, in the details, in the ones and zeros. From a Dapper perspective, or distributed application platform and runtime, the quick starts section is probably one of my favorites. So if you are going to look at this as a potential for integrating this into your application stack, this page will be very helpful for you. It kind of breaks everything down, gives you the ability to go through and set stuff up quickly, and kind of ties it all together for you as far as what the different components are and how you can go about actually using them in your distributed application. For Radius, here's the Radius page, and this is recently been added to the Cloud Native Computing Foundation's sandbox. So this is something that is out there, CNCF sandbox approved. And this gives you the ability, like I said, to be able to put together like an application graph. So you can see the different components within your application. You can see how they interact with each other. You can also take a look at things that are more cloud agnostic, being able to incorporate in different things in your recipes to put together a holistic idea of what your application or your platform looks like. Now, documentation is all fine and good, but we should probably actually look at some code. Now, I won't go out on a limb and say that this code is the best code. This is a lot of generated code that I've been, putting together over the past few days to make sure that we've got some sort of an example here to be able to use. So one of the things that I like to show folks is, and hopefully my IDE is not too small in the typesetting, but even if you were just to look at AZD once it's installed, it gives you the ability to go through and do a few different things. My recommendation is, whether you have access to an Azure account or not, go out and spend a little bit of time and put this through its paces. Test it out, kick the tires, whatever you need to do to make sure that you have a good understanding of how this works, because this is useful for more than just provisioning cloud infrastructure and then pushing your code to it, you can use this to also generate infrastructure as code that you can then go and look at, see how it's constructed, see how it's put together. And it gives you an idea of things that you might be able to add to it as well. So a little bit of time investment up front will pay off big in the long term for you if you've got some time to go and look at this. Always log in first. Just making sure that you've got all of your stuff set up, especially if you do have an Azure account already. Making sure that you have that attachment to a subscription will give it a bit more context and allow you to do different things, especially if you have the ability to directly create or deploy infrastructure. Some of the big things to keep in mind are the provision and deploy commands. Provision obviously sets up your resources. Deploy will deploy your code based on the templating that you have set up. I'm a bit more of a build purist, I suppose, when it comes to how I construct my pipelines and stuff like that. So I'll specifically put steps in there that will use .NET Build and .NET Restore and Clean and all of that stuff, the testing aspects of things, packaging and publishing. So this is meant to be somewhat of a helper for folks to be able to do all of those things without having to type out each individual command. I personally just prefer doing it the long way because I can see specifically what it's doing and I know that it's going to follow that chain of events. So why am I showing you all this? Well, the reason I'm showing you all of this is because we are going to follow the path of initializing this code base, which is really just a function app with one function called process upload, as you can see here, that processes a file once it hits a blob storage account. Okay. There's a flag here that you can use from code that will tell AZD to look at the code that you have and make recommendations around the type of services that would be good to run this code in. One thing that's great about utilities like AZD or .NET Aspire or anything else is that they're opinionated in how they present options to you for different types of infrastructure. One of the things that can get you in trouble is that it is opinionated about how it presents choices for infrastructure. So I'll show you what I mean. When I do this, it's going to come down here. It's going to detect, okay, you're running .NET. It's going to generate the files necessary to host the app on Azure Container Apps. Now, maybe you want to just use a function app and don't want to go into the whole setup of using a container app to do that stuff. Maybe you do. We're going to make the assumption that we'll accept this for now with the understanding that we want to look at the code that it outputs for the infrastructure. Okay. So we'll confirm. What port does it list it on? That's a good question. Typically, for function apps, it lists on 7071 when you're using the functions runtime and the hosting and all of that stuff. So we'll use that. And for the environment name, we'll use demo. And it creates an azure.yaml file, which gives you the ability to configure certain things. So this is basically your configuration for telling it what Docker file to use, where to pull the information from, and all that stuff. Now, the really interesting part is in the infra folder. And this is where you'll see things like app modules, shared type of code for different components that are in there. And you can see it generates quite a few things. And one thing that I like about using this as a mechanism for just creating the code to create your infrastructure is that it will give you things like a dashboard and key vault and monitoring. So it'll put together application insights for you. So if you're not sure of what to use for some of those components, this will give you a good baseline to at least start with. And you can make decisions later on about, adding or removing things based on the requirements for your application. But altogether, for example, this will give you bicep compliant code that will go out, create a key vault. One thing to keep in mind, if you've never seen bicep before, it tends to line things out as far as resources, the type of resource, and then the endpoint that Azure would use to create that resource, right? So you'll have the specific type as well as the date or the version of the API that it's going to be hitting to create that. It's part of the mechanism of bicep itself. That is also a conversation that can be 1 to 2 hours in and of itself, just around bicep. So needless to say, it's good to keep an eye on the stuff that's out there, watch videos, get yourself immersed in it, if that's something you're interested in. But you can see this goes through and creates all of this infrastructure as code for you. And you can use this directly to provision an environment, or you can, like I said, use it to inform yourself of how this is put together and then make modifications to it as you see fit. We're in the home stretch. So we're going to talk about now the pace of progress. And it's really interesting and really almost intimidating how fast things change. If you look at just, generative AI, for example, within the past 6 to 12 months, the amount of change and the amount of improvement that we've seen has been pretty remarkable. Something similar can be said for cloud services in general, in how features and different functionality are introduced either in a preview state or in general availability. I remember years ago, you used to have to wait, a couple of years for a release of Visual Studio or the .NET framework. And now it's difficult to even keep up with how many times .NET is being revised. I feel like as soon as you get comfortable using one version, the next one's already out, ready to go, with some changes that you need to keep in mind. So, it's okay. Don't panic. The rate of that change is going to outpace your ability to keep up with it. Guaranteed. So what I usually try to impart to people is focus on the things that matter to you in the course of what you're trying to build. If you want to look at different services, to experiment or to get a better understanding for how they work, totally fine. But don't internalize that and feel the pressure of all of those different changes happening all the time and the need to keep up with them, because it's going to be overwhelming and not one person can know everything about everything. So it's okay. When you're looking at services as well, look at the roadmaps. Not every service will do this, but a lot of them do, especially on the Azure side. They'll provide product roadmaps that will show you what they have planned over the next 6, 9, 12 months or so. And looking at that to see what's on the horizon can also help you plan for what's the best choice for me to host my application, knowing that changes are coming that may impact how that works. So just kind of some stuff to keep in mind. And with that, here are the links that I promised. Quite a few things that are in here. Some things around dev containers, around code spaces as well, to kind of give you a little bit of information around how that type of stuff can work. The code that I have in the demo is also going to be using code spaces configurations, so you can play around with that if you want to. but that's entirely up to you. That ends my time. Hopefully this was informative, and hopefully everyone enjoyed this. If anyone has any questions, I'm happy to answer those now.
Thank you, Josh. It's very interesting. And yes, guys, if you have any question, you can add in the comments. And also, we provide a voucher for best question. Exactly, it's a 50% discount for fundamental and enterprise voucher. But I think it's, you cover all of them, and maybe your reference link is very useful for all developers.
So I'm glad it's useful. That's all I can ask, is that folks find it interesting and that it helps them in their day-to-day. So
Yeah, nice, great. I think there is no question in the chat, and maybe if all of participants needed more help, you can connect with you in the LinkedIn or other guys. Maybe ask the question. Exactly, I think it's better.
Absolutely.
Yeah, nice. Have a good day, guys. Thank you, Josh, again for your interesting presentation, and we can end up this live session. Thanks.
Very good. Thanks for your time. Appreciate it.